So continuing on with the law of cosines, a golfer hits from the tee for a 300-yard hole. Her drive carries 275 yards, but is 13 degrees offline from the hole. How much farther must the golfer now hit the ball to reach the hole? So you can see that the target was this direction. Her ball goes this direction, so her ball's sitting here. She still wants to get into the hole, and there's a 13-degree offline shot there. So the distance she has to hit yet is going to be this distance here. So just to complete the triangle that we're looking at there. So generally when we're dealing with trigonometry, you want to see triangles in the world. So when you see an angle like that, then you just complete the triangle to create this image we're looking at. We're looking for the distance here. Obviously, if she had hit it straight out the hole, she'd have 25 yards left, but she's gone off line a little bit, so this distance is probably more than 25 by a little bit. Looking at the known information, we know this side, we know this side, we know the angle between, so the included angle. So we have a side angle side triangle, which tells us the law of cosines is usable. As you saw yesterday with the side angle side, the law of cosines, we first find x, so what we're looking for is the very first thing we would find. We don't care about these two angles here and here, we just care about the distance. So if I write the law of sines out like we did yesterday, the side opposite the known angle squared goes all by itself. And then over here we're going to put the two numbers Pythagorean theorem-wise squared. So 300 squared plus 275 squared. So again, that much of the law of cosines looks like the Pythagorean theorem. Then we get this extra term. Is 2 times something times something times cosine of something. So for law of cosines in general, the challenge of law of cosines is this extra term. If we could build the Pythagorean theorem, what I don't know squared equals what I do know squared plus what I do know squared. The two things that go here are the two things I know. And what goes there is the angle that's opposite this side, which in this case is 13 degrees. All right. And just like yesterday when you have x squared equals all that stuff in numerical expression, I can just type that exact expression in. I want to make sure my calculator is set to degrees. On the gray calculator, it has a little DEG on the screen to let you know. So if I type in 300 squared plus 275 squared minus 2 times 300 times 275 times, did I do minus name? Times, there we go, times 275 times cosine of 13. All right, so 300 squared, 275 squared added, minus 2 times 300 times 275 times cosine. So a bunch of multiplication there. Hit enter. That's what x squared equals. So x squared is equal to 4,853.9393. So to get x, I'm simply going to take the square root of both sides. So the square root of x squared and the square root of 4,853.9393. Comes out to 69.67. It doesn't specify how far to round. I'm going to go a couple decimal places. So x equals 69.67 yards. She still has almost 70 yards to go. Had she hit it exactly straight, she would have had 25 yards to go. So she basically lost 45 yards of distance by hitting it off to the left like that. And again, that's all they asked me for, so I would be done at that point.